e haere mai, and welcome to Daily Demos. I'm Miss McBride, this is Kind Koala, and this is Frankie, and somewhere in the room there is that cheeky bee. Okay, today we're doing a science experiment. The science experiment that we're doing is called Deggsity. Now, that's not really the word that I was meaning to write. We're meant to write the word density, but the density experiment that we're looking at today uses an egg. What you will need today is an egg. Kind Koala, could you get one? Frankie, do you want to eat that? Okay, let's try that again. What you will need today is an egg. Please be careful.
Okay. Tricked ya.
Koala loves playing tricks. Classic. You gave me a heart attack. Don't do that again.
Alright.
Okay, what you need today is an egg. Or two, it doesn't matter how many. A real one, not a fake one. Not a bouncing ball. You also will need some salt and some water. And you're going to need a spoon. Okay.
Now it's time for our opening karakia. Mahunga ki raro, heads down. Kia inoi tātou. Manawa mai te mauri nuku. Manawa mai te mauri rangi. Ko te mauri KO he mauri tipua. Ka pakaru mai te pō. Tau mai te mauri. Homi e, hui e, taiki e.
Okay, to start with the experiment, I forgot to tell you need a jar. Preferably a big jar, one that you can see quite easily through it, so not with a big sticker on it, and a tall one is really good. So the first thing you need to do is to put water into your jar. Fill it up about 2/3 of the way, so not quite to the top. Okay, now what do you think is going to happen when I put in an egg into the water? Have a think to yourself, talk to the person next to you or somebody at home. What do you think is going to happen to the egg? Okay, shall we find out? Great, so get your egg with me at home and pop it in the water. What happens? Does it float or sink? That's right, it sinks. And the reason for that is that the egg is more dense than the water. We'll talk about what that means soon. Okay, but what happens if you get some salt and your spoon and you start to add salt? Start with 1 tablespoon, give it a mix, and just keep adding until you see something change. Okay, after a while, what happens to the egg? That's right, it starts to float. And that's because the density of the water has changed now that we've added salt. We'll talk about that soon. But hang on, what happens if I get some more fresh water and I really carefully pour it in so that it doesn't mix? with the salty water. Now you can see that my egg isn't floating on the top, it's not at the bottom, it's in the middle. Why would it be sitting in the middle? Let's have a look at the board. So why does this happen? Well, once again, the why is really interesting. It's all about density. Density is not necessarily how heavy or how light something is, but it's how tightly packed the molecules inside it are. So, as we know, it doesn't matter how big or small something is. If something is big, it can still be much lighter than something that's small and heavy. Take an apple, water, and a coin, for example. If I had a glass of water and I filled it up, what would happen if I popped an apple inside it? Well, an apple would float. What would happen if I put a coin inside it? Well, the coin is metal and it has high density and it's heavy, so it would go to the bottom. Now, the real reason that this happens is because the molecules inside an apple, if we looked really, really, really close with a microscope, we'd see that the molecules are not super close to each other. If we looked at a coin really, really closely, we'd see that the molecules are really, really, really tightly packed, squished together, making it more dense. If we looked at water really, really closely, we'd see that the molecules were not quite as close as a coin, but a little bit closer than the apple. That means that the tightly packed, dense coin goes to the bottom of the water. The water that has quite close molecules sits in the middle, and the apple, which molecules is quite far away, sits on the top. Get it? Well, the same thing happens with the egg, the salt, and the water. Okay, so the water is not very dense. So its molecules, like I said before, are not super close. An egg, the molecules are quite tightly packed, which means that when I put my egg in the water, it's more dense than the water, so it goes to the bottom. But salt is super dense, so when I add salt to the fresh water, the molecules are much more tightly packed. So the salt water, the salt goes to the bottom. So this means that in my jar, when I put in the egg into the fresh water, it goes to the bottom because it is more dense. The molecules are more tightly packed than the water molecules. But when I add the salt has tightly packed molecules which pushes the egg up to sit on top of the salt. Which is why the egg floated all the way to the top when we filled it up with salt. Keeps going up and up and up and up. But when we add added more fresh water really carefully so it didn't mix with the salty water. The egg is more dense than the fresh water, but less dense than the salt water. So it sits on top of the salt water, but it sits at the bottom of the fresh water. So it ends up floating in the middle. There's another experiment that you can do at home that plays around with what is more and less dense than other things. What you need for that experiment is some syrup, maple syrup, golden syrup, any kind of syrup that you have, some oil, any kind of oil is fine. I've got some rice bran oil here, some food colouring of your choice, this is just for fun, don't have to have food colouring, and any household objects that you might want to test. So I might use my egg, I might use something like heavy, like a plug, I might use something like a ping pong ball or a little bit of foam. I might use anything around the house and I can have a look at what happens. Check out the experiment now.
First, let's pour in our water. Now pop in a drop of food colouring just for fun. Give it a mix. Time for the syrup layer. Pour in a syrup layer that's around about the same size as the water layer. Look at what happens to the syrup. Now it's time for our oil layer. Pour in about as much oil as you have water and syrup. Where does the oil sit? What do you notice about the density of each liquid? Where does each liquid sit? On the bottom, the middle, or the top? Time to test some objects. The plug goes straight to the bottom. How about an egg? Which layer will that sit in? How dense is the egg? It sits on top of the syrup, inside the water layer. Now let's try a bottle top. Let's see how dense the bottle top is. It looks like it's the same density as the oil because it sits in the oil layer, and a sponge sits on top. So the plug has the highest density, so it goes straight to the bottom through the syrup. The egg has medium density, so it can't get through the syrup, but it sits on top of the syrup layer. The bottle top has quite low density, so it sits inside the oil layer, and the sponge has even lower density, so it floats right on the top.
Okay, that is all that me and Frankie have for you today. I encourage you to play around with lots of different things in your house to see what is less and more dense, especially using your jar with your egg. Is there anything that you could put in there that would float in the middle, or go to the bottom, or float on the top? Okay, let's end our lesson with our karakia. Mahunga ki raro.
Kia inoi tātou. Ka pā ki toa, ka pā ki waho, ka pā ki te whare, ka pā ki te roa, ka pā ki te pau e tūnei. Kia mā te ariki, kia mā te tauira. Noho e rua tau e tāne te wairoa e. Whāno, whāna, haramai te toki. Homie, hui, tai ki e.
Ka pai. Thanks for a fantastic lesson. I look forward to seeing you next time on Daily Demos. Say bye, Frankie. Frankie says bye.